Okay, here we're going to look at the non-calculator part. We want exact values. You'll notice 1 and 2 are special right triangles. So here 45, 45, 90, it's isosceles. Both legs are the same. So x has to be 13. Meanwhile, y is that same leg times the square root of 2. So 13 square roots of 2 would be our y. On number 2, we know the long leg is 4. To get from the long leg to the short leg, you have to divide by the square root of 3. Then we have to rationalize that. So multiply top and bottom by square root of 3. So for x, we get the numerator is 4 square roots of 3, while the denominator is 3. A little messy. I can try to write that again. 4 square root of 3 all over 3. Then our hypotenuse, we just double our short leg. So take that, multiply it by 2. So multiply the numerator rather by 2. The denominator stays the same. So 8 square roots of 3 over 3 is your y. Number 3, we'd first want to do find the third side. You could use Pythagorean theorem, or if you realize this is a Pythagorean triple, so 3, 4, 5, but they're all tripled, so we get 12 here. Could have done 9 squared plus b squared equals 15 squared, though, if you weren't sure that, to get your Pythagorean, or using your Pythagorean theorem, you get 12. Now I can do all of my ratios. Sine, opposite over adjacent, 9 over 15. Oh, that simplifies to 3/5. Cosine, 12 over 15 simplifies also to 4/5. Tangent, 9 over 12 simplifies to 3/4. And then their reciprocals. Cosecant would be 5/3. Secant, 5/4. And cotangent, 4/3. Number 4, it might be helpful to draw a triangle. It doesn't have to be to scale. Give it a theta. It's a right triangle. We know that secant is the reciprocal of cosine. Cosine's adjacent over hypotenuse, so this is hypotenuse over adjacent. So we'll label your hypotenuse as square root of 73. Your adjacent is 8, and now we've got to figure out what the other side is. We can call it x if you want, or a for on your Pythagorean theorem, and do your Pythagorean theorem. Over here, the square and the square cancel, so you just get 73. Subtract 64 and 73, you get 9, so x therefore has to be 3. So we can come up here and put a big 3 there, and now we already know secant, but we have to do the rest of them. So sine would be square root of 3 over our hypotenuse. We have to rationalize it. Meanwhile, cosecant, prior to rationalizing, I had 3 over square root of 73, so reciprocate that, square root of 73 over 3. Cosine would be 8 over square root of 3, so 8 square roots of 73 over 73. We already knew what secant was. We already had that one that was given to us, so I can skip that. So tangent, opposite over adjacent, 3/8. So cotangents would be the reciprocal 8/3. All right. Number 5, we need to put 2, -2. That point, our terminal side goes through there. Well, that means that their x coordinate, if we make a triangle here, the x part, the horizontal part was 2, and then we went down 2, so that's a -2. If we do Pythagorean theorem, or actually you could realize that since those sides are congruent, one doesn't matter that one's negative, it's a 45, 45, 90 triangle. So this would have to be 2 square roots of 2, and the hypotenuse is always positive. Or if you weren't sure that, do Pythagorean theorem, but you end up with 2 square roots of 2. So that's the r. Here you can use this as x and y and r, or you can think of opposite adjacent hypotenuse however you want. And then we've got to find the 6 trig ratios. So sine, I'm going to think of y over r, so -2 over 2 squared, so 2. Well, first of all, my 2's cancel. And then I have to rationalize, so negative square root of 2 over 2. Meanwhile, cosecant would just be the negative square root of 2 over 1, so just negative square root of 2. Cosine x over the hypotenuse, or x over r. So we get just positive square root of 2 over 2. Meanwhile, secant would be the reciprocal, just square root of 2 positive. Tangent y over x, negative 2 over 2 simplifies the negative 1. And so cotangent is the reciprocal of that, which would also be negative 1. Remember, all seniors take calculus acronym. We're in the fourth quadrant, so cosine should be positive. The rest should be negatives. Cosine is positive, rest are negatives. That's good. All right, now we got 270. These are like our special right triangle quizzes. Oh, ends up being quadrantal. 0, negative 1 with an r value of 1. So sine is y over x, negative 1 over 1. Or sorry, negative, it's y over r, negative 1 over 1. I don't know why I wrote equal sign there twice, sorry. So negative 1 over 1. Meanwhile, cosecant would be the reciprocal of that, which is also negative 1. Cosine x over r is 0. Reciprocate that, we get undefined. Tangent's y over x, so 0 would be the denominator, so that's also undefined. So its reciprocal would be 0. All right, tangent of 150. 150 would be 30 degrees shy of 180. So it's a 1, square root of 3, to the left it's negative, and hypotenuse of 2, so tangent opposite was 1 over adjacent, negative square root of 3. We need to rationalize, move the negative out front, negative square root of 3 over 3. Secant of negative 480. So we're going to go negative full revolution. There's 360. So we still have another 120 degrees to go. So we end up out here. That's a 60-degree reference angle. So we have negative 1 there, negative square root of 3 there, 2 there. We want secant, which is the reciprocal of cosine. So we want hypotenuse over adjacent. So I call that negative 2. 13 pi over 6. We're going by 30-degree increments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So we went a full revolution and then back to just one of them, 30-degree reference angle. So that's a 1 out there, positive square root of 3 here, and there's the 2. Sine opposite over hypotenuse, 1 over 2 is 1/2. Secant of 11 pi over 3. We're going by thirds, so 60-degree increments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We end up right here, almost 2 full revolutions. We went around once and then back to here. That's a 60-degree reference angle. 60 is over there, so square root of 3 here. It is down, so it's negative. 1 would be here. It's to the right, it's positive. There's our hypotenuse. Secant, once again, is the reciprocal of cosine, so we want hypotenuse over adjacent, which is just 2. Thanks for watching.